Imagine walking outside tonight and looking up at the sky. Everything seems normal. Except for one thing, the moon is gone. Not hidden behind clouds, not experiencing an eclipse. It has completely disappeared. At first, you might think nothing has changed, but the moon has been influencing Earth for billions of years, and its disappearance would begin changing our planet almost immediately. The first difference would be obvious as soon as the sun went down. Nights would become dramatically darker. The moon is by far the brightest natural object in our night sky, reflecting sunlight back toward Earth. Without it, stars and the Milky Way could become much easier to see in places without artificial light. There would be no more lunar phases, no crescent moon, no full moon, and of course, no more solar or lunar eclipses caused by the moon. For humans living in cities, this might initially seem like little more than an astronomical curiosity. For nature, however, the consequences would be much more significant. Now, let's look at the oceans. The moon's gravity is one of the main forces responsible for Earth's tides. As our planet rotates, the gravitational interaction between Earth and the moon helps produce the familiar rise and fall of ocean levels. If the moon suddenly disappeared, the tides wouldn't disappear completely. The sun also produces tides. But without the moon, the familiar tidal patterns along our coastlines would become much weaker and very different. And that might sound like a small change. It isn't. Entire coastal environments depend on regular tidal cycles. Mudflats, tidal pools, salt marshes, and countless other habitats exist in a world shaped by the constant movement of the ocean. Change the tides, and you begin changing the ecosystems that evolved around them. Some organisms would lose feeding grounds. Others would face completely different conditions for reproduction and survival. And the consequences wouldn't stop at the shoreline. Because for many animals, the moon isn't just something in the sky. It's a clock. Countless species use moonlight and the lunar cycle as an environmental signal. For some animals, the moon helps determine when to feed, when to migrate, and even when to reproduce. Corals are one remarkable example. Some coral species synchronize mass spawning events with particular phases of the lunar cycle. In the ocean, many other creatures also change their behavior depending on the amount of moonlight above them. And on land, the story continues. Predators can use bright moonlit nights to hunt. Prey animals may become more cautious when the landscape is illuminated. Sea turtles also depend on natural light cues when navigating near beaches and the ocean. If the moon suddenly vanished, one of nature's oldest and most reliable signals would disappear with it. But this doesn't mean every ecosystem would collapse overnight. Animals can adapt. Over generations, many species would respond to their new environment. But feeding patterns, migration, reproduction, and the delicate balance between predators and prey could all begin to change. Humans would probably get used to a moonless night surprisingly quickly. For wildlife, the adjustment could be far more complicated. And yet, even these changes would be small compared with what could happen to Earth itself over millions of years. But the moon does much more than illuminate our nights and influence the oceans. It also plays an important role in the long-term stability of our planet. Earth doesn't rotate perfectly upright. Its axis is tilted by about 23.5 degrees. That tilt is one of the main reasons we experience seasons. And over extremely long periods of time, the gravitational influence of the moon helps stabilize Earth's axial tilt. If the moon disappeared, Earth would not suddenly tip over. Tomorrow would still look almost completely normal. Even thousands of years might not reveal dramatic changes, but over millions of years, Earth's axial tilt could become less stable and experience much larger variations. And that could have enormous consequences. Imagine the tilt of Earth gradually changing. Some regions could begin experiencing far more extreme seasons. places that are relatively mild today could face incredibly harsh winters, followed by much hotter summers. Ice sheets could expand into regions that are currently temperate. Elsewhere, changing sunlight patterns could transform forests into grasslands or deserts. Ocean circulation and atmospheric patterns could also respond to a changing climate. These changes wouldn't happen overnight. They would unfold across timescales far longer than human civilization has existed. But eventually, a future Earth without the moon could have climates very different from the planet we recognize today. And even then, we still haven't reached the end of the moon's influence, because the moon has also been quietly changing the length of every day on Earth. The connection between Earth and the moon has been slowly changing our planet for billions of years. The gravitational interaction between them creates tidal friction, and over enormous periods of time, this process gradually slows Earth's rotation. Long ago, a day on Earth was significantly shorter than 24 hours. As the moon interacted with Earth's oceans, our planet's rotation gradually slowed, while the moon slowly moved farther away. Even today, the moon continues to drift away from Earth by a few centimeters every year. So, what would happen if it suddenly disappeared? Earth would not immediately begin spinning faster. Our 24-hour day would remain almost exactly the same. You wouldn't wake up tomorrow to 6-hour days or see the sun racing across the sky. Instead, something much slower would change. Without the moon, its contribution to tidal breaking would disappear. The long-term evolution of Earth's rotation would begin following a different path. This is another important theme of our moonless Earth. Most of the truly enormous consequences wouldn't happen in a day, a year, or even a human lifetime. They would unfold across thousands, millions, and potentially billions of years. So let's travel far into that future. What would Earth actually look like after living without the moon for millions of years? Imagine Earth millions of years after the moon disappeared. Humanity, assuming we were still here, would have long since adapted to a world without it. Entire generations would be born having never seen the moon with their own eyes. They would know it only from photographs, videos, books, and stories from the distant past. The night sky would be dramatically darker. Far away from city lights, the stars and the Milky Way would dominate the sky. Coastal environments would have adapted to much weaker lunar tides. Some species might disappear, others could evolve to take advantage of completely new conditions. And over immense periods of time, changes in Earth's axial behavior could contribute to very different climate patterns. But despite everything we've discussed, Earth would survive. The oceans wouldn't suddenly disappear, the planet wouldn't immediately freeze, and humanity wouldn't instantly go extinct. The disappearance of the moon would be less like an instant apocalypse, and more like changing one of the fundamental rules that has shaped our planet for billions of years. Fortunately, the moon isn't going anywhere tonight. It's still up there, slowly moving away from Earth by only a few centimeters each year. So the next time you look up and see it in the night sky, remember, the moon isn't just something beautiful to look at. It's part of a gravitational relationship that has helped shape the Earth we know today. But now imagine something much worse. What if tomorrow morning the sun disappeared? What would happen after 8 minutes, after 1 hour, after 1 day? And how long could humanity survive? That's a story for another time.